So some more Babylonian quadratics, some more techniques. One question that's kind of interesting is where the given information, instead of giving a sum and a product or a difference in a product, give something else, like the sum of the squares and the sum of the two numbers. They could say, like, geometrically, the sum of the areas of the two squares is 244 and the sum of the two sides is 22. The way you do a question like this is you square the 22. 22 squared is 484. You subtract the 244 from the 484. And what we've accomplished with that number, this 22 squared is the same thing as x plus y squared, which is x squared plus 2xy plus y squared. When I subtract the 244, which is x squared plus y squared, I end up with 2xy, which is 240. And if I divide that by 2, I get xy equals 120. So I've now gotten back to my original kind of question. Two numbers, x plus y is 22, x plus y is 22, and xy equals 220. I solve that by taking half of the 22, squaring it. Whoops, it should be 120. Subtracting 120 from that to get 1, take the square root of that as 1. And 1 plus 11 plus 1 is 12, and 10 are going to be the two numbers for x and y. So what started out with an unusual piece of given information eventually turned into this. In this question, we're being told to find the sides of a rectangle if the area is 168 and the diagonal is 25. So if I kind of go x, y, and there's a diagonal, I get, like before, x squared plus y squared equals 25. And the area is xy equals 168. It's a little bit like the last question, except I have different given information. If I multiply xy times 2, I get 168 times 2 is 336. If I take x squared plus y squared, and is 25, and I add on 2xy equals 336, I get 361 is x squared plus 2xy plus y squared. But adding 2xy to this thing turns it into something that can be factored. So it becomes x plus y squared equals 361, and take the square root of both sides and get x plus y, I think it's 19, equals 19. So now I managed to get from this given information the value of x plus y. So x plus y is 19, x times y is 168. X plus y is 19, x times y is 168. The process is divide 19 by 2, square the answer, oh, I knew something went wrong there. The equation should have been 25 squared. Sorry. 25 squared, I think is 625. So put a 6 there. That changes this to a 961. And then the square root of 961 is actually 31. That's better. Sorry about that. 31. So the process is divide that by 2, get 15.5. Square that, get 240.25. Subtract 169 and get 71.25, and then take the square root of that. Uh-oh. Never mind, this is supposed to be 168. Sorry for this sloppiness. 290.25 minus 168 is 122.25. Take the square root of that. Still a problem. Hold on. Okay, let me just get my mind set here. So, half of 31 is 15.5. 15.5 squared is 240.25. Take away 168 and get 72.25. Square root of 72.25 is 8.5. 15.5 plus 8.5 is 24. 15.5 minus 8.5 is 7. This is the answer for x and y. Sorry for that confusion. Okay, another question I want to show you is where you're given the product plus the difference, and you're given the sum. And it says a sneaky method where you add the two equations together and you get xy plus 2x. The y's, this is plus here, the y's cancel out and we get 44. Then we factor out the x. Then we come over here and add 2 to both sides because we have y plus 2 here. So we make that into a y plus 2 to get 15. And now we basically have two things whose sum is 15 and whose product is 44. I'll just call this A and B just to remind you of how that works. So it's like AB equals 44. A plus B is 15. You take the 15.
Excuse the interruption.
You divide 15 by 2 to get 7.5. You square that to get 56.25. You subtract 44 to get 12.25. You take the square root of 12.25 to get 3.5. You do 7.5 plus 3.5 to get 11. 7.5 minus 3.5 to get 4. So if the 11 is the x, then the 4 and the 4 is the y plus 2, then y would be, let's then subtract 2 because we want to know what y was, would be 2. So 11 and 2 does work. 11 times 2 is 22 plus 9, which is 11 minus 2, and 11 plus 2. So 11 and 2 is one of the answers to this question. I think we could have also made the x 4 and the y plus 2 11, so it would be 4 and 9 would be the two answers. That works also. 4 plus 9 is 13, and 36. Oh, that one doesn't work because 4 times 9 is 36. It's already but then the x minus y would be negative, so that would work also, but I think they would want to have the x be bigger for this question because x minus y would be something positive, so these are the two answers. Okay, finally, a question like this, 12x, x squared plus 12x equals 85. If it has an even number here, there's a sneaky trick you can do. The Babylonians were well aware that x plus 1 squared equals x squared plus 2x plus 1, and they would use this. So this 12x, if we do 12 divided by 2 and square it, it becomes 36. If you divide everything by 36, 85 over 36, this can turn into x over 6 squared, and this thing can turn into 2. This whole thing reduces to 1/3, which is 2/6. So it turns into 2 times x over 6. And this thing is still 85 over 36. Notice how this has the form x squared plus 2 times something. So then you add 1 to both sides, and you get x over 6 squared plus 2 times x over 6 plus 1. 85 over 36 plus 1. 85 plus 36 is 121 over 36. This thing now factors to x over 6 plus 1 squared equals 121 over 36. Take the square root of both sides. X over 6 plus 1 equals 11 over 6. And then subtract 1 from both sides and get x over 6 equals 5 over 6. Which means x equals 5. So in review, you take this number, divide it by 2 and square it. You divide everything by that number. And when you do that, the first term can be rewritten as x over 6 squared. The second one will always turn into 2 here, and whatever was over here will end up there. Well, those are some other techniques for Babylonian quadratics.